Okay, we want to examine problem number 2 of the practice test I gave you. A freely falling object requires 1 second to travel the last 35 meters before it hits the ground. From what height above the ground did it fall? And we want to do this problem in the outline I gave concerning knowledge, understanding, application, and evaluation. So let's first start with knowledge. A simple statement that this problem applies to 1D uniformly accelerated motion, or that it applies to free fall motion, or that it applies to 1D uniformly accelerated motion, specifically free fall, would be sufficient for a first statement indicating that you have knowledge of what this problem deals with. The next criteria is understanding, and with understanding we have the process of diagram, explaining the variables, making sure you know the unknown, and that you have some understanding of the equations involved. So first start with understanding. We have a particle at y0, t0, v0. It just begins to fall. It passes y1 at some time 1 at some velocity v1, and it finally hits the water or hits the ground at some velocity v final at y final and t final, where y0 is your start height, t0 is your release time, v0 is your start velocity, y1 is 35 meters above the ground, yf is 0. We don't know v1, we don't know v final, we don't know t final, and we don't know t1. We know the difference though is 1 second. So we have at least 4 unknowns. So we're going to need quite a few equations in order to solve this problem. What is our unknown? We're asked to find the height above ground. We want y0. Okay, let's enumerate the possible equations that will come into play with this particular problem. We have, of course, the standard equation V average, yf minus y1 over tf minus t1, which is immediately calculatable. We have V average is equal to the final velocity plus the initial velocity over 2. And then we have our standard velocity equation. The final velocity is equal to the velocity 1 minus the acceleration due to gravity times tf minus t1. And then we have velocity final equals velocity 0 minus the acceleration due to gravity times the total time of fall, tf minus t0. And then finally we have the total height of the fall, y final minus y0 is equal to minus 1/2 acceleration due to gravity times the total time of fall squared. Solving for the equation, the first thing I write down is this equation right here, simply because it has our unknown in the equation. And yf is 0, so I can write it in this form. Now, I need tf minus t0. Well, I have an equation that gives me tf minus t0 right here. And solving for tf minus t0, I get it in terms of the final velocity over the acceleration due to gravity, which I'm going to plug right into my y0 equation. But I'm still left with having to find out what this Vf is. Well, I have 2 equations that involve Vf and V1. Both of those are unknown at the time. Vf plus V1 equal 2 times the average velocity, and Vf minus V1 is equal to minus g, acceleration due to gravity, times the final time minus the time at position 1, or 1 second. Adding these 2 equations, we can solve for the final velocity and obtain it in terms of V average. Now, V average is immediately calculatable. We can find it because we know what YF is, we know what Y1 is, we know what TF is minus T1. That's 1 second.